All right, guys, so today we're going to introduce the topic of an absolute value function, and we're going to see what its graph looks like so that by class time tomorrow, we're going to be able to graph all different kinds of absolute value functions. So first, I want to compare every absolute value function to just the basic line, basically what it would look like without the absolute value sign. So we're going to look at, first of all, y equals x. We're going to graph that. I'm going to graph it in the graph on blue. So when we graph a line like this, first we're going to look for that y-intercept that's on the end, and there's nothing. It's almost like it's plus 0. So I'm going to put my y-intercept on the graph. And then next I'm going to look at the number in front of x, which in this case is 1, and that would be the slope. And so this slope tells me that to get to the next point, I'm going to go up 1 and over 1, up 1 over 1, 1 over 1. And I'm going to kind of continue it down here a little bit. So that if I were to go ahead and connect all these points together, I would have a nice straight line. Okay, so that's what y equals x looks like. But now we want to learn how to graph y equals the absolute value of x. And really in your mind, you should be saying to yourself, well, it's really similar, but at the same time, absolute value makes all my numbers positive. And so how is that going to change this region of the graph down here? What's going to happen to this region in the third quadrant? Because all of my numbers are now going to become positive. All of my y values now become positive. So some of you might be able to make that connection right away. But for those of you that don't really know how that will change the graph, let's go ahead and plug in some numbers. If you plug in numbers like 0 and 1 and 2 into the absolute value function, they still come back as 0, 1, and 2, because all we have to do is take the absolute value of them. But if we go ahead and plug in numbers like -1 and -2 and -3 into the absolute value function, they're going to become positive, 1, 2, and 3. So now we're going to go ahead and graph those as points on my graph. So we still have 0, 0, and we have 1, 1, and we have 2, 2, just like we did for our line. But on the other side of that, we will have -1 and +1, -2 and +2, -3 and +3. So what happens is on this side of the line, or sorry, on this side of the y-axis, we have our line, just like y equals x. But on this side of the line, we have another line like y equals x, just going up. And really, so what that absolute value function did was it took all of this region down here in quadrant 3 and it flipped it up above and made everything positive. So your basic absolute value of x function looks like this big V. And if you notice, on each side, the slope is 1, up 1, over 1. And over here, we're going back 1, up 1, back 1, up 1, or basically up 1 and left. So they they have the same kind of rate of change, except one side is negative and the other side is positive. All right, just to kind of emphasize that part of what my point is, talking about that slope or that rate of change, if we went ahead and graphed y equals 2x, once again, our y-intercept does not exist. Well, it does exist, it's just 0. Our slope is now 2 over 1, so we're going to go up 2 and over 1, up 2 and over 1. And we would have a nice looking line down 2 and over 1. Nice looking blue line with a slope of 2. Looking now at our absolute value function, where it's 2 times the absolute value of x, if I go ahead and make myself that table of values, on my right-hand side with the 0, the 1, and the 2, if I plug those in, I'm going to get back 0, and then I'm going to get 2, and then I'm going to get 4. And when I go ahead and I plug in my negative numbers like -1 and -2 and -3, it's going to make them positive. So when I plug in -1, it's going to get back 2. When I plug in -2, it's going to come back with 4. If I plug in -3, it's going to come back with 6. So if I go ahead and graph these points, 0, 0 is the same, 1, 2 is the same, 2, 4 is the same. So this side looks the same. And on the left-hand side, -1 now pairs with +2. -2 is with +4. -3 is with +6. This side looks equally steep. It's got the same slope, but it's going back the opposite direction. So hopefully by this you will understand, what does the general absolute value of x sign look like. They always look like this big V. And what does this number in front of the absolute value sign describe to us? Well, hopefully you see that it describes our slope. And on the right-hand side of the y-axis, it's our slope exactly. And on the left-hand side of the y-axis, it's completely the opposite of our slope. Meaning right over here, my slope is actually, if I go from one point to the other, I've actually gone down 2/1. So my slope on the left-hand side is -2/1. And that will be true for all absolute value functions. Okay, make sure that you have all the graphs in your notebook and that you understand those things. See you tomorrow.